Audio Jungle. Audio Jungle.
Here we'll talk about types of loading. Types of loading. Okay. Types of loading. Now these types of loading divided can be divided in four basic loads. First one is the concentrated load. Concentrated load. Second one is nothing but uniformly distributed load called UDL. Okay. Third one is nothing but uniformly varying load UVL. And the last one, what we have, last one is nothing but bracket load. It's a special type, so we'll see bracket load. So these are the types of loading we are getting on the beam. Now I'll show you with in the beam, and I'll show you the calculation also how we have to perform if UVL is there, if UDL is there, or bracket load is there, then how we'll perform that we have to see. One by one we'll see. First we'll see the uh, number one, which is nothing but concentrated load. So concentrated load concept is very easy. huh? Concentrated load means, suppose this is what beam, this is the beam now. Okay. And we have a supports, something like this. This is support, this is, you say, RB, and this is what, RA, because this point is A and this point is B. Now the load is what, acting at one points. If it is acting at one point, suppose P, so this P is nothing but concentrated load because it is acting at point. I must write at point. If any load is what, acting at one point, at one particular point, some particular distance, suppose here the distance is nothing but 2 meter. So at this particular point, whatever the load is acting P, it is nothing but concentrated load. Okay. It is also sometimes called a lump load. What it is called? Lumped load. Concentrated load, or it is also called lumped load. So lumped load or concentrated load will be acting at one specific, one particular point, and it is fixed with some, with the distance of with any distance from any end, maybe the end A or end B. Any distance will be possible: 1 meter, 2 meter, 3 meter, 4 meter, whatever it is. But it will be fixed. It is not going to vary now. That is called concentrated load. Okay. So its calculation will be very easy, like RA horizontal, all vertical forces upward will be positive and downward will be negative, so RA plus RB is equal to P. That is the calculation of it. That is the calculation, right? And how to calculate the, reaction force, that, you take moment about any point and then you write the equation. One equation will be the moment equation, another equation will be RA plus RB is equal to P. Then you use two equations, solve two equation, two unknown, two equation, you will get the value. So it's very easy, that. This is all about concentrated load. Now we'll talk about UDL, because that is important. UDL, UVL. So how that UDL loads will act? So uniformly distributed Uniformly distributed load. Right. How it how it is? See, you can show the beam. This is what now beam on a straight line. Also, if you show, it's okay. This is now beam. This is the beam. We are having the support at this end. This is support. Okay. You say this is point B reaction RB, and this is reaction RA at point A and B. How the load is acting? So UDL load is what? It's a name only you can understand. It's a uniformly distributed load. Means it is distributed. It is not acting at one point. It is distributed. Something like this, just like an iron chain. No? If you see the chain will be something like this. You can spread. So this UDL is what is spread up to this distance. It can distribute that UDL can be possible up to full span of the beam also. It's not like only any, it is not specific like this distance will be there only. It can be at any distance. It can be spread up to full span. It can be spread up from one end. Suppose it is only 2 meter, right? So the intensity of this load will be given like 2 Newton per meter square, something like this. That load will be given. Sorry, not meter, meter square. It's a meter only. Sorry, 2 Newton per meter. It's a intensity of the load. Okay, it's a intensity of the load. Always remember, it is called intensity of load. So how it is solved now? I can say now for this particular, two things you need to remember. First, UDL need to convert into concentrated load, because it is spread to the span it is spread on the span of the beam to some specific length. So once you are going for the calculation, so first you convert that UDL into concentrated load. It's very easy. How you can convert? See the method. It is 2 Newton per meter. Means if you see what is the concept of it, in 1 meter 2 Newton load will be acting. That's the mean of it. Yes or no? That's the mean of it. So how many meters it is spread? It is spread to 2 meter distance. Hence it is 2 into 2. That means 4. 4 Newton load will be concentrated load for this UDL. That is point 1. You have achieved. Now what is the point 2? The point 2 is because concentrated load you have calculated, that is 4 Newton. But well, it will act. So where it will be act? So acting point of concentrated load for the UDL. So acting point will be the mid of span. If I say mid of span, it doesn't mean the complete span AB. No, this is point C. A to C only it is spread. So acting point will be the mid of span till UDL is available. Simple language you can understand. So till what span length UDL is available? It is A to C. So mid of A to C will be the point where the total concentrated load will be acting. Now you can find it. What is the mid? Mid is what? Somewhere here. So this is now, this point is now your concentrated load, which is equivalent to UDL. What is equivalent to UDL now? Concentrated load will be 4 Newton. So this 4 Newton, once you have written 4 Newton, then 2 Newton per meter, now it is gone. It's not required because you have converted in constant. This 2 Newton only you have converted into concentrated load, right? UDL you have converted. This UDL was, what was the intensity of UDL? It was 2 Newton per meter. Now you have converted in concentrated load. What is this concentrated load value? This 4 Newton. Where it will be acting? It will be just half of the span. Means it will be acting at 1 meter. And this side 1 meter. I hope this one is clear. So this is all about UDL. Now the third one, which is nothing but uniformly varying load. Okay. So concentrated load is done, UDL is done. Now third one is nothing but uniformly varying So it is not distributed, it is continuously varying. Both are different. It is uniformly distributed, means everywhere with the same intensity it was distributed. 2 Newton per meter. So if it is, you are talking about at 2 meters, so 2 into 2, 4 Newton. Again, it's still 6 meter, it is spread, then 2 into 6, till 8, 2 into 8. So distribution is what uniform actually throughout the span of the beam. But if you talk about the varying, so variation is what, like this. Suppose this is the beam now, this is the beam now, and this beam is what, maybe supported by you. It can be anything, it can be simply supported, it can be overhanging beam, anything possible. So now I'm taking simple one, it's a simply supported at this end, and obviously at this end also simply supported. So this is the reaction Ra and Rb. You say point A, this is point B. Now how you will show the uniformly varying load? So if it is uniformly varying load, so it will be like this. See, it is continuously varying, it is not constant at all. Obviously I can take this distance, I can take this distance, and it also depends, even though UDL also, it depends what is the direction. So here it is acting in this way, but doesn't mean that UDL or UVL, it can also act from downside. I will show both, I will show both, otherwise people may get confused. That also possible, maybe this or maybe this, both are possible. Okay, both side it can act. Always remember, suppose now this is the beam, same beam we have here. So here beam, on the beam load can act in this way also. Okay, in this way also, vertical direction, upward, this is also possible. So whenever you will solve the problems, you also see the direction of the loading. For the UDL also it is possible, maybe UDL is what acting here, and UDL you can, so here also it is also UDL. So that time all the concepts whatever you are applying for the upper side UDL, the same concept you have to apply for the downside. Okay, it's not a difficult task, it's very easy. All right, so anyway, now what to do for this? So we are talking about this also. Okay, about this, suppose intensity of load, sometimes they will give the value, sometimes it will be variation like omega or small w, means that in that way also they will give. Okay, so how you will recognize it's a UDL UVL? So that unit will be the same, UDL and UVL. UDL throughout the span it will be constant, it is not going to vary, but for UVL it is going to vary. Just for example, I will show you, it is what is at this point, what is the value of UVL? It will be 0. Continuously it is increasing, so just say it is 1, 2, magnitude is continuously increasing. Check 5, 6, 7, like that it is increasing or not. See the magnitude of the length of this arrow, you can understand this is the value of or you can see this is the measurement of how that uniformly varying load is what that value is what increasing, that's the mean of it. If I want to show the UDL, then how UDL by the arrow, how I can show you? So UDL I can show, suppose this is the beam, so UVL I can UDL I can show you in this way by the arrow. Also here also I can show you like this. See, this is the arrow, by the arrow I can show you like this. See, throughout this is constant or not, same arrow we have, same length of this arrow we have, that means it is constant throughout the length. Here I can say 2 Newton per meter, means throughout the length it is constant. But here it is not constant. If you check the even arrow size also, it is continuously increasing. So what is the mean of it? Meaning is that's the reason it is called uniformly varying load. It is continuously varying, it is increasing or decreasing, it can be anything, but it is varying, it is not constant throughout the length. If here it is 0, then maybe further it can be 20 Newton per meter, that possible, because here it is 0, it can be 10, 20, anything, but it is constant, it is varying. But here if you see, from first, from here it is started by 2 Newton per meter, so here also it is 2 Newton per meter. So that's the reason it is called uniformly distributed load, but this is called uniformly varying load. Here it is varying continuously. Hope you understood. Now how to calculate this? So first you see up to what span it is spread. So A, B, I can say this is sorry, this is the point I can take. This is nothing but C I can take. So till A to C it is spread. First of all, A to C. I can say this length is nothing but, just for understanding, 6 meter, and this point is nothing but C. So up to what distance your UVL, uniformly varying load, is what acting? It's a till 6 meter only, and it obviously it is acting vertically downward. My resultant load will also acting downward in that way. I can show this. Suppose this one is the beam and this is the simply support here. Oh, sorry. I should not give this. I just want to show you that beam width. Separately, I will show you. This is nothing but somewhere here. Now it's fine. So this length is the same diagram I have taken here. It is spread up to 6 meter, and this value is nothing but 20 Newton per meter. Here it is 0. Now my job is to convert this UVL, first point UVL, we need to convert into concentrated load. How will convert? See, it is continuously varying from one to into another end. It's a kind of triangle. So what is the concentrate loaded now? What is the concentrated load now? Just listen carefully, you will understand. The magnitude of concentrated load is nothing but area of triangle. What is the area? A, C, this is C now, and this is what? So triangle ACD. You have to write the triangle ACD area. Area you have to write. What is that? 1 by 2 base into height. What is base? 6. What is the height? 20. So it's nothing but 60 Newton. So 60 Newton is the concentrated load. You have converted UVL into concentrated load, and concentrated load will be acting at one point that you know very well. So what is that point? So we have to find the centroid of the triangle. We know the centroid, how to get the centroid, because centroid is the point where the concentrated load, converted concentrated load of UVL will be acting. So now this is my triangle. This length is nothing but 6 meter, and this side length is nothing but, you can say, 20 Newton per meter, like that. Okay. Anyway, if I'm interested about centroid of this, so centroid will be what? Triangle centroid, you know. Okay, I will show you that vertical triangle, so you will more clear about it. Suppose this is this is my base. This is what? Height h. Yes or no? So I had already explained. If you talk about the CG of this, so from here this CG, because this side weight mass distribution will be more, so CG will be nearer to this side. So this side it is h by 3, and from apex side it is 2 h by 3. Many times I had explained about the CG. So this is your CG. So from this end, what is the length now? It's nothing but, apex side it is nothing but 2h by 3. Okay, that means 2, what is the h? It's a vertical height. Vertical height, if you check, it's nothing but 6 meter. 6 divided by 3, it's a 4 meter. So at 4 meter distance, our concentrated load, what we had calculated, it will be acting. Okay, that is the CG location. Yes or no? CG location. It's a 2h by 3 from the apex, this side. So now if you talk about the CG location for this UVL, if you see, so from this side, our distance 4 meter will be acting somewhere here. So this is nothing but 4 meter. So whatever the UVL you have converted into concentrated load, and that magnitude is nothing but, what is the magnitude of this? Magnitude of this is nothing but 60 newtons. Your 60 Newton is what acting. Now once you have converted UDL into concentrated load, then there is no use of 20 Newton per meter and all. That's all. This is all about uniformly varying load. What is important? Now, like once you convert uniformly load into concentrated load, then what is the formula? So formula is what? The triangle area, huh? 1 into base into height. That is the concentrated load. Now second point is where it will be acting. So that location of concentrated load. So location of concentrated load is nothing but centroid of triangle. That's all. So you have calculated 2h by 3 from the apex side. From base side also you can measure, it's your choice. If you measure this side, so it's nothing but h by 3. That means 6 by 3, which means 2 meter. So it's your choice. If you are measuring from the base side, so it's a 2 meter. Generally we'll measure from the apex side. This is uniformly varying load. Now we'll talk about the concentrated load. Bracket load. Last one. Last one is the bracket load. Okay. So till now what I have explained. So from there only this bracket load generally comes. Okay, you see it's very easy, and but it's very important at the same time. Suppose this is the beam. This is the beam. Okay. Now here we have support on this beam. I can say it's again simply supported beam. It's simple only to show you, since I'm showing you simply support. Now where generally this is what, see, I will show you all. This is the concentrated load. Okay. This is the UDL load. Okay. This is the UVL load here. Now I want to show you the bracket load. Okay. So how the bracket load will be acting? So bracket load will be something like this. See, load is what acting here. This is Newton. Okay. They will give this distance also. Just say 1 meter. Separate I will show you. Don't worry. Suppose this is the beam now. Check, concentrate. It's very easy. You will understand. This is the beam now. This is the support now. Now concentrated load will be acting something like this. See, this is what clamp 4 meter, and they will show you this distance also. They will show you, nothing to worry. Okay, this distance they will say 2 meter. Now this type of loading we called as a bracket loading. So what is the calculation? You concentrate, it's very easy. Once you talk about this beam, so you will get it, the same beam you will have here. See, the same beam you are having here. The same beam you are having here. So red by red lines. It's very easy, but if you don't know concept, then it will be very difficult sometimes. So the same beam we have here. Okay. Now I just want to resolve this bracket loading. Just like a UDL you have seen, UVL we have seen, we have converted into concentrated load. So once you see this bracket load, so where it is acting, just say this is point A, this is point B. Obviously reaction will be RB, reaction will be RA, right? And this where the load is what acting, just say it is acting at point C. So now this load is what acting at this end, but indirectly that effect you will get at this point C. This is the point C. The whole loading 4 meter effect you can shift, because this is the clamp, this is the fixed rod, this is the rigid. It is not flexible. It is not you can say movable. It's a fixed only. So that's the reason whatever 4-meter load you will apply, it will exactly acting at point C. So this 4-meter load where it was acting at point D, but easily you can shift from D to C, because this 4-meter it is acting at point D, but this is completely clamped, fixed, clamped, rigid clamped. It is not flexible, it is not movable. So whatever the load it is getting at point D, the same load will be experienced at point C also. So this 4-meter you can shift, but problem is not shorted now. This concentrated load you have shifted from D to C, it is okay. But you can think this length you have now, and if you see 4-meter, sorry, this is not 4-meter, this is 4 Newton. No? I am sorry, this is 4 Newton. Please correct this. This is the 4 Newton, not 4-meter. It's a 4 Newton. So this 4 Newton load, will be shifted from D to C. That is okay. You can easily experience that. Like if load is what acting at point D, and this rod is what clamped, fixed rod, it is not flexible, it is not movable. So same force will be experienced at the point C also. That is true. But you also can think D and C, because load is what acting at point D, and about C it will give the moment also. It will try to rotate this clamp about point C. So at the same time at point C, because of this 4 Newton, you will get the moment, and that moment value will be 4 Newton into perpendicular distance from C. What is the distance from C? It's 2 meter. So 2 meter into 4, that is 2 into 4, which is nothing but 8 Newton meter. It will give the moment, and that moment will be clockwise, because if see the moment, if you see the force 4 Newton, it is going downside, and if it will rotate the object, it will rotate the clamp about point C, and that direction will be clockwise. So for that reason here, whatever the moment you will get, it will be clockwise moment. Okay, and that magnitude is nothing but 2 into 4, 8 Newton meter. It's very easy. Now if I want to show you this, suppose this is 2 meter, just for example. So I want to show the load, then what will be the load here? Obviously this, the 20 Newton load you can shift here, no doubt. Now you have shifted here, this is 20 Newton, but this 20 Newton will give the moment also at this point, and this is nothing but 20 into 2, which is nothing but 40 Newton. 40 Newton meter. 40 Newton meter, not Newton per meter, Newton into meter. That moment unit is Newton into meter, right? So this is called bracket load, and definitely it is very important. Sometimes if you don't know concept, then it is difficult to solve that. That bracket loading can also be possible in the different way. Like, yeah, I also can show you. If you want, check, this is now beam, this is now beam, and for this particular beam, suppose how that bracket loads also you can show. This is the reaction. Now if you want to show the bracket load, so see, you can show bracket load something like this also. This is also possible. Check. Now you can see the load is what acting in this way. Okay, and also you can say the load is what acting in this. Just think about it. This is nothing but 2 Newton. This is also 2 Newton, and this distance is 2 meter. This distance is also possible. Anything can be possible. This end is A, this end is B, this end is what, C. So how to show that? How you will solve this? It's very simple how this bracket loading will be solved here. So I must show this beam, same beam I'm taking downside also, so it will be easy for you to understand. Okay, and check here. I can give, this is what support, this is what supports. I am interested about this bracket loading, so see, this is point C. Now first this 2 Newton you have to show exactly at point C, because I told you this is point D. So the load will be shifted from D to C, because from where the clamp is what attached, it is attached exactly at point C. So now this vertical load will be shifted from D to C. So this 2 Newton is what shifted. But what about this 2 Newton? The story is what not end up here. This 2 Newton basically will give the moment about point C. See this, because it's not a vertical load, it's a horizontal load. So obviously this will try to, this 2 Newton horizontal load will try to move this beam also, but this beam is what you can say it is fixed at this point. So one reaction force will be acting at RB horizontal, and that will be exactly 2 Newton. That is one, it's okay, no problem. But this 2 Newton will also give moment at point C. And what is the moment? 2 into 2, this perpendicular distance from C. This load is acting at point, you say it is E. Load is about acting at point E. So 2 Newton into perpendicular distance for C, it is 2 meter. So 2 into 2, that is 4 Newton meter will be the clockwise moment. Just listen carefully. It will be clockwise 4 Newton meter. That is true. What about this 2 Newton downside? It is also acting. So this 2 Newton will be first shifted at point C. That is true. But this 2 into again perpendicular distance from C, it is nothing but 2. So 2 into 2, that is 4 Newton meter, but it also provide clockwise moment. So two moments will be acting here. It is also 4 Newton per meter. 4 Newton meter. So exactly if you see 2 Newton, because of this will get vertical load. This 2 Newton is horizontal, so we cannot show vertically. This 2 Newton will be obviously will be getting horizontal direction, just opposite, equal and opposite. That is horizontal reaction force. But moment, if you check, this force also will give moment 2 into 2, that is 4. So 4 plus 4, it's nothing but 8 Newton meter. That is the exact. So this is the way to solve the bracket loading. Hope you understood this.